Good day, folks. This is a video tutorial 20, which goes into a playlist called Mechanism Design in 3D Experiences platform. I will be creating this very simplified version of a single cylinder engine, and uh, just to show you how things are, at least in the part that we cannot see, there is a pin here. There is a pin here that connects the connecting rod to the crankshaft. Okay. Now, as far as making this is concerned, I'm not going to worry about any dimensions. I just do a top-down approach. I start making things irrespective of what the physical sizes are. But I'm going to be consistent. I'm going to do it all in the same essentially assembly as a top-down approach. I'm not going to create the parts individually and then bring them in. So there's going to be a piston like that, a connecting rod, con rod, a crank, obviously a pin that's going to go into that hole, and a block. Now, this block, I also arrange it so that the bearings are belonging to the block. So these bearings are not separate, are not in a separate part. It's just belongs to the block. Okay. Now, this is an exercise in that book from back about 8, 9 years ago, but the instructions here are all based on 2016, release 2016X, but the video tutorial that I'm making is using release 2025X, okay? In fact, this is a simplified version of a slider crank mechanism that I did earlier in one of the tutorials in this playlist. Keep in mind that although at the end, once I create my model, I can put some physics into it. In other words, just like I did for the case of slider crank, I can specify for example, the speed of the crank, and based on that, I can get the information about velocity, acceleration, etc. of different parts. I'm not going to do that. So essentially, I'm going to make a cartoon, except that if you want, you can put the physics into it later on. Okay. So let me go ahead and start the process. Why don't I start with the piston first? So right click. This is the entire assembly. Right click, insert 3D part. Okay. And the way I'm going to do the piston, I will create a profile and then shaft it. Okay. So let me call this thing piston though. Properties. Call it piston. 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 I'm going to get rid of the stuff. Okay. All right. So let me double click on the part. So as I said, what I'm gonna do is to create something that looks like a cross section of the piston, and then I'm going to shaft it. So on that vertical plane, I will sketch. And to make my job easier, I make sure that everything is symmetrically constructed so that it minimizes the amount of effort that I have to put later on uh, in assembly. Okay, so here's going to be my piston. The profile looks like this. Perhaps let me do it like that. These are for the piston ring. Okay, and I can't remember how many of these did I have here. Yeah, just one slot. That's fine. So we go down like so. Okay. Now the only thing is that I think this is too far, so let me move these things a little bit further to the left. Yeah, that's better. Now I want not a flat face, but perhaps an arc type thing. So let me go ahead and use a 3-point arc. 3-point arc, maybe 1 point, 2 point, and hopefully this comes in tangential. It really doesn't matter. Okay, so that's going to be my piston. You see later on what I'm going to do, exit, and then we will shaft it. So let me go ahead and let me see if I can find, here's a shaft, that, about the Z axis. Okay, and then we say okay. All right. Now, what I will do is I will uh, create these flat sides here. Or is that these flat edges? So let me go ahead and do that. So on that vertical plane, I will sketch maybe a rectangle like that. Okay, that's good. Exit and pocket it all the way in both directions, perhaps. Okay, so let me go to the pocket, do it symmetrically here. Right here. Double click on the pocket. Okay, so we do it symmetrically. Good. And I can make a pattern on the other side. There I go, right there. So not pattern, I'm going to mirror it on the right hand side. So probably on the transform, mirror, not the whole thing. I want the mirror pocket with respect to that vertical plane on the other side. Good. So it looks like this. Now on that plane, I will sketch a circle. That's where the pin is going to go later on. Yeah, that's fine. Exit and make a pocket all the way through. Let me see now, where is this pocket? To last, perhaps. It goes all the way through. You can see that. And finally, to hollow this out, I'm going to use the shelling operation. So let's see if we can find the shelling operations here. It's probably under, let me see, essential. There it is, shell. I'm going to select faces to remove is this, and make sure you also select that the face of that hole. Otherwise, it will you see actually this cylindrical surface later on. Okay, so let's make this thing for now. I don't know. Well, let's see how it looks like. Okay, I'll make it a little bit more, maybe 0.05 perhaps. It's nicer. Yeah, sure, no problem. I'm not concerned about dimensions here, so there we are. So this is the piston. We did that piece. Now let's go and do a connecting rod. Okay, this is the connecting rod. So we go here. Let me do a quick save. So, yeah, all the way to the top. Right click, insert 3D part. Or by the way, notice that you can also say, for example, display action pad. you get the basic operations out of this. I don't like to use this much. I'll go back to right click, insert 3D part, and I'm going to call this thing Conrad. So right click, properties. I'll call it Conrad. 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 Say okay. Let's go make it. Double click. Once again on that same vertical plane to make my job easier. I'm going to project that circle. So let me project the circle. And then I start making my connecting rod based on that. So let me look at from the view from the front and make the connecting rod. So here's how I'm going to do that. I'll clean it up in a minute because I would like to get some symmetry involved into this. So I'll clean it up. That's terrible. Okay. All right, so let's see now. First of all, I want this and that to be concentric with each other. So this circle control that circle. And I go to, instead of dimension, I go to constraints to find the dialog box. And I say concentric. Oh, they are concentric. That's good. That's good. Now I want this and that to be, or maybe this to be tangent to that. So this line, control that line, and tangent. Okay, good. I want this line, control that line, control the middle axis to be symmetric. Vertical, I want symmetric. Okay, and this to be tangent to that. So this control that to be tangent to each other. And I'm pretty sure because of what I did, this point lies exactly on that axis. If it's too tall, you can lift it up, etc. But that's good for me. So exit and then pad it symmetrically. Well, that's too big. Maybe 0.1, how it looks like. Yeah, sure, why not? Okay. All right, the only thing is that I need a hole at this end. So let me go back to that sketch. That sketch where I did the pad. I draw a circle here. This is where the crankshaft is going to go into. There, exit, and then there's going to be a hole down here. Okay, good. So let's do a save. I'm going to do the pin. So let's go all the way to the top. What do I mean by the pin? The pin is this piece that goes into that hole. Okay. So right click, insert 3D part. I'm going to rename it to be pin and pin. That's just a cylinder basically. Let's go and make it. So on that same vertical plane, I will sketch. And to make my job easier, I'm going to project that circle once again. I mean, look, you can make these pieces separately and then put it together if that's what you want. I don't want to do it like that. So then I'm going to pad it. Pad it. Oh, we have to exit this. Pad it. Why don't I do the following? Why don't I do between these two planes, between this plane and that plane? So let me go, let me see, what's the best way of doing this thing? Maybe up to plane, up to this plane, okay? And then I also want to do it on the other side. To do on the other side, You've got to go to second limit, again up to plane. That's going to be this plane. Then we say OK. So you can see that the plane is made right there. The pin is made. Quick save. We're going to make why don't I make the block first? The block is basically this piece. Okay. So let's go ahead and make the block. So all the way to the top. Right click, insert 3D part. I'm going to call this thing the block. Properties, block. The only reason I'm doing it like this is because I want to minimize the amount of work that I do when it comes to assembly. Okay, assembly constraints. Block. Let's go make it. Okay, and how I'm going to make it, this may sound weird to you, but just look at it for a second. On that vertical plane, on that horizontal plane, I will sketch. We're going to project the circle and clean it up. What do I mean by cleaning it up? So first of all, I'm going to draw a line. Well, let me do a profile from here to here to here, and I will make it symmetric in just a minute. Okay, so let's make sure that this control the middle axis. They are symmetric. Okay, good. And then I'm going to trim this. Okay, so let me go and trim it. Let's see now. I'll do a quick trim. That piece is gone. Exit, and then pad it. Let's go further higher up here. So what you see there is the top face right there. And then I have to go further down. And to go down, I go to the second limit. Let me go, okay, by dimension, let me go further down here. Very good. But I also want to make these two bearings here on the, where is that, on the side. So this is what I'm going to do. On that same sketch, actually not on that sketch, on that vertical plane, once again, on that vertical plane, let me do it differently. On this vertical plane, I will sketch, project that circle, project this circle, say OK, make another circle concentric with it, right? Exit, pad it, too much, made it 0.4, let's see how it looks like. So this is going to be my bearing. I want one exactly on the other side. So let me, you actually use a mirror there. So mirror this with respect to that middle plane. And there we are. So what I have here is my, this is my bearing. Now, if this is too tall for you, what I can do, I can make it a little bit shorter. Let's go back here, make it 2.5 so that you can see things better. There, okay? Now, the final piece to do is the crank. So we go all the way to the top, right click, insert 3D part. Let me call this thing crank. Crank, and crank. Okay, let's go make it. Now this may be kind of strange the way I'm going to do it, but bear with me for a second. Okay, so on that vertical plane, the middle plane that I'm using for, because I want to, because I'm lazy. All right, so I'm going to project that circle. So project that circle. Good, and I'm going to start making the rest of the shaft. I'll do half of it and then mirror it on the other side. So exit, add it. Let me see how this is supposed to look like for a second. Yeah, okay, very good. So pad it the other way because I want to see it better. And this is too much, maybe 0.5, maybe 0.4. Okay, now on that plane, I will sketch this the rest of the crank. So maybe something like that. See for a second. Yeah. Oops. Hang in there. Let me do it again. I don't like the way I was doing it. So okay, good. So the rest of the crank. So yeah, we'll clean it up. Not to worry. Okay. Let me actually hide this. Hide this so that you can see it. But let me hide this for a second so you can see it better. A couple of things I want to do is I want to make this I want to move this thing up. Well, first of all, I want to make this. Well, let me put that point on that vertical axis. Control. Is that the one? Yeah. Coincident. Make it a little bit better. Okay. I want to move this a little bit up. I can do that. And make this tangent to that. Control this. Tangent. And I want to make it nice and symmetric. Oh, how about this? Control that. Also tangent. Okay. And how about this and that symmetric with respect to the vertical axis? Now, let me see for a second. Yeah. So this control the vertical axis, which is right here. Make it symmetric. Okay, good. And let's go ahead and exit and see what's going on. First of all, this guy is in hiding. Let's get it back because I want to see it. Okay, good. So I'm going to pad this. That profile, I'm going to pad it. Yeah, sure. Fine. And I just noticed something, and that is it was a bad idea to project that because this circle, it looks like I projected that circle. Did I? Yeah, I did not want to project that. So that we have to fix this for a second. Okay. So here's what I'm going to do. A couple of things. First of all, I am going to back to block. I don't like that uh, bearing that I made, go to that sketch. Okay, they really did not want to project this. Okay, so let me do the following. Let me do, when you project it, you cannot resize it, etc. So I'm going to right click and isolate. Now when you isolate, notice that the color changes from yellow to no color. So now I can resize stuff. Okay, and I want to move it further up. I want to move this thing further up. Now it may not let me do that because this was concentric. This circle was concentric with it. Okay, so here's what I'm going to do. I'm going to delete this. Now I can move that up. Still keep it on that vertical axis. Okay, so now I'm going to make the maybe a little bit further up. Okay, that's yeah, that's good. And now I draw my concentric circle and exit, and there we are. Okay, so notice that I did clean up a few things. So what I'm going to do is to go to the 3D shape for crank. On that plane, I will sketch. Now I'm going to project that circle. Remember the one that I moved? Project that circle. Say OK. Exit. And now pad it. Maybe more. Yep, that's good. All right. So this pad is in the crank. Okay, now I'm going to mirror these guys with respect to that vertical plane. So while I'm in this crank, so I'm going to say mirror. On the transform, for example, or a few other places, I can say this guy, the other, these three pieces. Okay, so it's going to be, I already did, let me see, I already did pad 3, but I did pad 1, pad 2, and pad 3 with respect to that vertical plane, and I say okay. So they all end up on the other side. Okay, so let's do a quick save here, and we are good. So let us go and do the assembly. Notice that there's only 3 planes here. That's because of the way I made it. Actually, there is multiple planes sitting on top of each other. So why don't I go to the assembly first of all. Go to the assembly. Okay. All right, go to the assembly and fix the block. So under assembly, under engineering connections, we're going to say fix the block. Okay, good. Now I'm going to move things apart and assemble it in a minute. So let me see now, maybe use the different ways of doing it. For example, you can use the manipulate, you can translate, okay? You can translate, let's say in the, I don't know, Y direction maybe? Or along the Y direction. So let me move, there is the connecting rod, there is the crankshaft, there is the pin, and there is the piston. Okay, and then we say okay. All right, so let's put it together. First, I'm going to put the crankshaft in there, and this is going to be a revolute joint, a revolute between this axis or this axis, this between a revolute between this and that. Okay, from the crank and crankshaft and the bearing. So let's do a revolute. Okay, between the way I'm going to do that is line and line, plane and plane. So let me see now. Line and line and plane, and because at the end of the day I will put some physics into this thing by turning this thing, I will also use the angle between two planes as the driving controlling entity. But anyway, what I'm using is number 4, this one. Axis to axis, plane to plane, and for controlling the speed and things like that later on, if you want beyond cartoon, this, 2 planes. So I'm going to use this template. So it's going to be this axis and that axis, this plane and that plane, and for controlling things, it's going to be the angle between this plane and that plane. Say okay. Say okay. And update. I think I picked my axis incorrectly. Let me undo this last one. Let's go back here. Revolute. Let me see now. This axis and oh, should have been the other axis. Okay, so this is not correct. Right click, clear selection. I want, okay, so clear selection on both of these. Clear selection. Okay, let's try it again. I want this axis and that axis. I selected the wrong one. Okay, very good. Excellent. Good. Let's put the connecting rod in there. So it's going to be another revolute between this hole and that. So let's go ahead and do that. Let me update here. Good. Another revolute. Same thing between this axis and that axis, and this vertical plane and the vertical plane of the vertical plane for the let me see now, we're dealing with the crankshaft here. So yeah, XY of the crankshaft right there. That's okay. And I don't need this last one because it's not I'm not controlling it. Now let me show you something else. It may bother you that this thing moved to the other side. That's because of the way I selected these. So let me show you. Cancel that. Let's try it again. Revolute. I want the connecting rod to move. So this and that, and the vertical plane of the connecting rod and the vertical plane of the crank. See that? No big deal. And I don't want this thing because I'm not controlling it, so I'm going to delete that, and I say OK. You want to make checkpoint? No. Good. Now let's put the pin inside of that. So we're going to go with another revolute. Now this inside of that, I'm going to make it rigid, because if I make it a revolute or a cylindrical, it can spin about that. And basically, I'm assuming that this pin is rigidly fixed inside of that. Okay, so I'm going to make it rigid. I use, for example, the different ways of doing it. I can use the pieces, so the planes. So let me cancel that for a second. Cancel that. First, let me place it there. Okay, so one way to place it there properly, you can snap it. For example, you can say snap this and that. Okay, good. Now I can make it rigid. Okay, so create a rigid between well, I can use this feature between this and the sure, the Conrad. Finally, I'm going to put the piston inside of that. So the piston with this fellow is a revolute. This fellow is a revolute. So let's go and do a revolute. Again, we use this fourth one. So let me do that. So this axis and that axis and the vertical plane of this and the vertical plane of the pin, for example. I can use the pin. I believe it's XY. And then we say, okay. Now, one other thing. Oh, I don't need this. I'm not going to be controlling it, so delete this item that controls things. The only thing that I use for controlling is the angle between uh, the, uh, the block and the crank. Now we say okay. Now notice that this block can actually tilt in this direction. It can tilt in the rotate about y. I don't want that, so I want a cylindrical between this axis of this and uh, the axis of the block. So let's go and do a cylindrical, if we can find it. Axis to axis, we can do that. All I need is this axis and that axis. There are many ways of doing this thing, and I don't need any one of these. So I'm going to delete this, and I'm going to delete that, and close it. No. Okay, assuming that we did not forget about anything, let's go ahead and see whether actually we can move things around. So let me go ahead and do a manipulate, and I'm going to rotate and make sure the constraints are respected. And rotate about, let's say, this axis, okay? You see? Good sign. Good sign. Cancel. Okay, very good. So get rid of that. Let me close all of these. Update. Okay. All right. So we're going to go to mechanical system design. Okay. Create the mechanism representation. Let's check out what we've got. Sure. 1 degree of freedom, as we expected. Because we deleted some of these entries in the dialog boxes, these are becoming non-drivable. The only thing that is drivable or controlling is the angle between the block and the crank. We say, okay, let's check it out. Okay, good. Let's see. You see? Of course, this is just a cartoon. There's no physics in there. So now we're going to go put the physics in it. For example, we specify some arbitrary velocity for that. And if you want to do that, you're going to go to mechanical system experience. So we don't want to create the mech scenario yet. Say okay. Good. Okay. And now we're going to say, all right, let's do a law excitation. The thing that we want to control is that command, that is the angle between the crank and the block. This. Click on f of x. You can put a constant speed here. Constant speed, for example, I don't know, maybe 1 turn underscore minute. Actually, let me make it 60 RPM, 60 turn per minute times time. Okay. Now, if you want to create a kinematic scenario, well, this is the excitation law that we created. And the duration, let's put down, let's make it maybe 3 seconds. If you do 3 seconds, this should turn 3 times. This should go up and down 3 times, unless I made a mistake somewhere. And let's make this thing 0.1 so that we can see things better. Let me say OK, and run it. Compute. 1, 2, 3. Except that I think it was, let's animate it, see what happens. Do I get 3? It's too fast. 1, 2, 3. Okay. Rewind. Try it again. 1, 2, 3. Okay. Very good. And then, so we have a physics here. If you want, you can, for example, find out what is the velocity, of the piston, what is the acceleration of the piston, etc. So the only boo-boo that I made here was that when I tried to create this shaft, I projected that circle. That's why I had to go and clean it up. Okay, I had to isolate it and move it up a little bit. As I said, I did the top-down approach. Everything was done at the same time without any dimensions. It's up to you, of course, how you want to try this. Good luck, folks.